everyone, this is Clever Coding with the 10th video of the series. So before starting out this video, I want to give a few pointers related to the two previous videos we've uploaded. The two videos were about file handling, input file streams and output file streams, and we didn't get into that much detail. So in this video, I'm going to give a few pointers out in the beginning. So before starting out our code, I introduced all the skeleton, the necessary requirements, what we need for our program to run. And then, for instance, if we have a input file stream, we already have a file. Hypothetically speaking, suppose we have a file already existing in our PC, and we want to read it. And then I could say input file stream, and this is like the data type what we said, and the variable will be ifile, and you can name whatever you want. And then inside you could write your file name, whatever you want, right? And I've been doing .open in my previous video, but I want to clarify you guys that you don't have to write that. You could, in input file streams, you could it's not necessary to write the .open. Without is okay too, but in output you have to write the .open because you're gonna be creating a new file if it doesn't exist. And also, if it does exist, it will overwrite the file in output. Okay, in output cases, but in input cases, it will only read if it exists. And if it doesn't exist, it will give you an error. So if that case does occur, you could write something like, for instance, if I have some random file, I say test.txt. Okay, so I want to open this, and if it's not there, you could write if ifile, and then this exclamation mark indicates not, negation. So .is underscore open is a function what we're going to use, and this indicates if the file does not exist, if it's not existing. So what we say error, or we print out an error message to the user to indicate that the file does not exist. And then, well, better programming practice is to exit out the code to not cause that much confusion. Just exit out the code by exit 0, and your program will terminate if the file doesn't exist. And if it does, it will ignore this if statement and go after whatever the code's written after this will execute. Okay, so that was the first tip I wanted to give. The second tip is, what if you don't have that file, that text file, or whatever the text file you wanted to read, not in that specific location in your directory? And this is a fancy term. A directory is a fancy term for folder. And you know, in your computer you have dozens and trillion and so many folders you have, and this is like one of the folders I'm currently running my program in. This is called the C++ folder that I have in my C drive, users, Harris desktop, and then C++. And you can see my name is code 15, and code 15 is over here. So, and I could only read, I'm restricted to reading only the text files which are located in that specific directory. Now, I can't read my text files which are in my desktop, or I can't read them where my pictures are, my music is, or any of other those folders. I could only be restricted over here. And if you want to make your program be better, you could include that. Like if, for instance, I don't want C drive, I could have E drive. So if you want the E drive, you can have colon, and then you need to introduce 2 backslashes. If conventionally you see programs with this // but // 2 / introduce a comment, and we've been discussing this, and the compiler turns crazy when he says that. So for ignoring all these kind of confusions, we could just include these 2 backslashes. And then, for instance, if the E drive has a text file called sample, I'll just write out the name.txt, and you know what? That's all we need over here. And if that sample text file exists in that E drive, it will read it, whether it's in that file, whether it's not even in that file, that program file isn't even in that text file, it will still read it. So that was another tip I wanted to give. Okay, so now we'll be writing a program that will read a text file or any kind of file from the user, and then convert that file to a modified version, meaning that any kind of file existing in the computer will be converted to a new modified version without defecting the original file, and that will be all capitalized. So So we're gonna start by including some strings. I'm gonna have in string I file, or I could say in file, because I know this is the input file we need, and we need another string called out file. Okay, so why do I need these two? I'll need these both now. We've been doing in the previous videos like input file stream or output file stream, but we haven't done a program that has both of these functions together. So now we're having a program that will be having both of these functions together, because we need to read a specific file and then we have to write a new file modified using a program logic. So first of all, I'm going to console out and I'm going to say enter file name. And this is basically the file name, the input file name. And I'm going to say scene in file. And now we're going to say enter output file name. Okay. Okay, so just to make it a little more clear, we'll say enter input file name over here. Okay, so now we've included input file name and output file. And note that input file name has to exist in the PC for this to work. So after that, we say enter output file name, and we could say cin output file. Okay, so now including our input file stream, so input file stream, I file, and then we could say something like in file, because we've already discussed we don't have to put the dot open operation for input. You could if you want, but it doesn't bug you. Okay, so now output file stream, and then you have O file. And what you could do with O file is you could say dot open, and then you could say out file, OTFILE. And now why am I writing these variables instead of the text file explicitly? Because I'm already storing them in some kind of variable in the beginning, which is a string, and then I don't have to write that crazy text file in a string format. I'll just have to write the variable, which is much easier for me. So now we're gonna declare a character C. And now why do I declare a character C? We're basically gonna read every single text, every single letter in the text file, and every single letter is made up of characters. So I made a character C, and then it says I file C. Now what's happening over here is that the I file, or maybe the in file, what was basically the name of it, it's gonna read through that input file, and it's gonna read every single character, and it's gonna skip all the white spaces, all the leading white spaces. Now this extraction operator basically ignores all the white spaces. So for instance, if I have a comment over here, I say this is a boy. Now what do you think the compiler will read? It's gonna ignore this space, it's gonna read this, it's gonna ignore this space. So basically it's gonna ignore this, and then it's gonna ignore this space, and then it's gonna ignore this space. So you're gonna see the compiler reading this is a boy like this. Okay, and then it's not even gonna have that enter key, meaning anything after this, like he is 9 years, something like that, it's not even gonna have that enter key, because the enter key is also a white space. So it's just gonna have every single thing on a single line, which is not human friendly, and it's not good to see. So for that case, I won't introduce ifile extraction operator. Instead, what we've discussed earlier in the last video, we could include infile.get function, what I recommend everyone to do, and then we could put the character inside. Okay, this always overwrites, the compiler always gives this infile.get function, and then you put a C inside. Now C is the character, so it's gonna get it, it's gonna include all of those white spaces, so that it could be human friendly to view. Okay, so now after this, now while, we'll put a while loop, and we'll say we've discussed .good function in the beginning, right? And that means until the file marker isn't appearing. So we could also include like this, a logic in file, meaning in file if the not in file dot endo eof function. Now EOF function is also standing for end of file. So if the end of file marker didn't appear, this is what the code is basically saying. So what do you want me to do? I'll say an if condition, and because we want capital letters, we'll say if the character is greater than or equal to A, and operator character is less than equal to Z, small z, okay? So if they're lowercase, if the character is in between lowercase a and lowercase z, I want them to be capitalized. So C is equal to C subtracted by A and plus capital A. Now, you might be wondering, why would I even do such a thing? Now, the thing is, C is the character, okay? It could be any kind of character. And for this case, we could assume that maybe it's small a, lowercase a. So this is basically dealing with the ASCII table. So to be honest with you, you have to open up an ASCII table to understand what's going on over here. You have an A, for instance, your character is A. So it's A has an ASCII value of 97, the lowercase. And then the lowercase a, it's being subtracted by 97 again. So if it's subtracted by 97, meaning 97 minus 97, which is 0. If I have something over here called 97, is the ASCII value of lowercase a, and then 97 again, then you already know it's going to equal to 0, right? So after that, it has an addition to capital A. Now capital A value is 65 in according to ASCII. So all of this will equal to 65 capital A, meaning that lowercase a you had in your input, whatever the text file had, it would subtract from 97 small a and then add capital A to it, which includes the capitalized letter. So to have a better understanding, I'll open up an ASCII table online. So this is ASCII-code.com, and you could see the values of so many ASCII letters, and they go from 0 all the way to 127 conventionally. And over here you could see 97 as small a and 65 as capital A. Now why is the capital letters before small lowercase letters? Because the fact that computers started out as just capital letters, and then with the passage of time, the computer engineers and the programmers discussed all of this, and they introduced, the American standards introduced lowercase as well to make the text more human friendly and pretty to be appearing. So it just started out as just capital letters, and then after that lowercase also was introduced. So that was out of the way. I'll put that link of the website in the description of this video. I'll drop that link down in the description so you could view it out. Okay, and so after this we have the output file. So I say I want to write the file, so I could say output file and then insert it, right? This is the insertion operator. And we could say output file and we could say C. Now why would I even say this? Because I have a get file and you want this extracted like this, which will make the thing even harder for it to print out. So now after this I would have I file or the in file. I'm keep on mixing that up, and have the character again reading the next character. So this will keep on going until the end of marker appears, right? End of file marker. So after this I'll close this, meaning as infile.close, and another one as outfile.close. So I need to close all of these to make the code work. So I'm gonna save this. Okay, so when I execute this code, I came across so many errors, and the thing is that this happens in programming and this is normal. Okay, everyone faces errors. Okay, so the thing is I had to include .c underscore string function and .c underscore string function over here as well. And over here the .open function wasn't that necessary. Without .open is working fine as well. So if I put .c underscore string, the output file will be converted into a string C string format, meaning the character arrays what we've discussed. And character arrays are easy to manipulate for this compiler, so that's why I made it .c underscore string. Maybe in other compilers it works without it, but in this one it's working with it. So then after that, I needed to get c is equal to I infile.get. Now the thing is that I made this name as ifile, right? So why am I writing infile? Infile was the name of the string. So that was also another problem over here. So you can see that line number 17 has this problem that string has no member named get. So if I delete that in and make it I, it's going to be way better. And over here as well. And then you could see over here out, instead of out it had to be O file, because the output file stream O file was defined as the file name. So O file and then I file over here. Okay, then over here as well and over here as well. Okay, over here is the I file extraction operator, which will ignore all the leading white spaces, but we don't want to do that. We want to read every single line, right? So for that case we need to include in I file dot get function. Okay, so this will work out, and I hope this will now work properly. So all these other errors you can see right here. Now if I compile and run this, processing C plus 0 errors, and look, my terminal screen just appeared. So an input file name. Now the name of the text file was lorem, so I say lorem lorem dot txt. And then the output file, what I want to make it to as a new version, modified version, so I could say lorem modo.txt. Enter. That's it. What now? What happened? Go to your directory. So if I go to that C++ directory, you could see a lorem modem appearing right now, 757 757. So just right now the program just created a text file lorem modem. So if I open this, you could see all of that text, that crazy text that was in lorem is now in lorem modo, but with a modified version in capitalized letters. Now all that formatting is also done, meaning the spaces are neatly arranged in that proper order. And if I compare with the other lorem, which was the older version, you can see that the same exact thing, but with lowercase letters. And now that other lorem, meaning this one, the lorem modo, has the capitalized letters. I hope you like this one program. And now I want to show you one other thing that I could do. And I want to give this example to you all, that if I don't include this get function, what will happen? For instance, I would just put I file, and I'll just input something like extraction operator, and over here as well, which is get function, and instead of get function I'll just write I file and extraction operator. So what will happen if I save this and execute this program, compile and run? Now, oh yeah, I forgot one more. So now save and execute, compile and run. Same file, lorem.txt. And now remember that we could also make it as any kind of file we want. Not only txt, but we could also make a cpp file, which are C++.py file as a Python file, or any kind of file we want, an mp3. You could see that pictures like JPEG. I know it's crazy, but JPEGs and these kind of files also have so much data written inside of them to display a certain image. That's just craziness. And that's how all computers work, just by data. Binary 0 and 1, 0 and 1, 1 and 0. Okay, so now I'll make it as lorem1.txt. So for an example, I want to show you what happened now without including the get. Now you know the get function meaning it gets all of the lines in a sequence without worrying too much about the white spaces, right? But the extraction operator ignores all leading white spaces. So if I open up my file over here, which is lorem1, you're gonna see a clot of so much data that is like garbage to us. It doesn't even make sense. Now what's happening over here? It had look, I told you guys that the row will just keep on going until it reaches some case, but in this case it was restricted to that much columns, 1025, and then after that it just moved to the next row. And you can see this is just nonsense. You can't understand what's going on here, but you know that the program has done something by converting all of these letters to capitalize. So that was it with this video. In the next video we'll discuss something called getLine functions for strings and getLine for C strings. So see you in the next one. Bye guys.